Good evening, everyone. Welcome to NPTEL tutorial session for the course Principles in Organic Synthesis. So, today is our ninth tutorial session. Let me share the slide first. I hope it's visible and my voice is audible as well. So, in the last week, that is week 9 lectures, mainly we have seen nucleophilic aromatic substitution reaction. So, previously also in week 8 lectures, we have seen lectures about electrophilic aromatic substitution reactions as well as nucleophilic aromatic substitution reactions. So, in the last lecture, we have seen several named reactions as well, including Schumann reaction, Ullmann reaction, Stephens Castro coupling in the first lecture, and then several other reactions, including Ziegler alkylation, Chichi-Babin rearrangement, Smiles rearrangement, Bamberger reaction, and Bucherer reaction in the second lecture of week 9. So then what we have seen is that a particular type of mechanism that is taking place for the nucleophilic aromatic substitution, that is SRN1 mechanism, which takes place via free radical intermediate, which can be initiated by solvated electrons photochemically, electrochemically, or thermally. So it is actually proceeding via the normal radical process, that is via initiation to create a radical, then propagation and termination. So most of the reactions which we have seen in the week 9 lecture, we have already discussed some of them in the last week tutorial session. We have seen some problems also regarding that. So today what we will be doing is we will discuss some more problems, including this nucleophilic aromatic substitution reaction, and once it is finished we will move on to the discussion of week 6 assignment questions. Then we can brush up all the topics as well. So first, let me go to the questions regarding the nucleophilic aromatic substitution and the related named reaction. So directly we will be moving to question session today. So this is the first question. Predict the major product of the following reaction. So this particular compound is treated with this DMSO, potassium tertiary butoxide, ammonia photochemically, which will be the major product out of the four options given here. So I will give you some time to think about this. Sorry for that. So here the correct answer for this question is this one, that is option A. And what is happening here is this is an example of nucleophilic aromatic substitution reaction. So what is actually happening here is this oxygen lone pairs will push towards this bond. So this will shift over here This bond will shift over here, and this will be attacking over this bromine center, that is nucleophilic aromatic substitution is taking place, and this will leave out as Br minus. So what this potassium tertiary butoxide is helping in taking up this proton, so that that lone pair or this negative charge will be falling over here, and this reaction will happen to form this 1 2 3 4 5 6 membered ring will be formed here. So the correct answer will be option A. So it's an example for SNAR reaction, nucleophilic aromatic substitution reaction. Moving to the next question, predict the major product of the following reaction. So here we have this hydroxy naphthalene and also this phenyl hydrazine. When we are treating with this sodium thiosulfide, what will be happening? Not sodium not sodium hydrogen sulfate, or we can say it is sodium bisulfite. So reaction of hydroxy naphthalene with this phenyl hydrazine in presence of sodium bisulfite, which will be the major product here. So here the correct answer is this one, that is option C. And this is an example for Buchera reaction. So this mechanism we have seen in a last tutorial session as well. So here what is happening is that, so first our compound, so it is, yeah, this one, first one. Once it's get protonated, it will be forming, or in the presence of acid, we can say, yeah, in the presence of acid, it will get protonated, and this species will be forming, which will be resonance stabilized with this structure. That is when this oxygen lone pair will fall over here, the carbocation will be formed at this position. So another thing is that it can also exist in this particular resonance stabilized form, and that carbocation at this center can be stabilized by this sodium sulfite ion, that is NaSO3 minus, to form this particular intermediate. So this 3B is the reactive species which is formed by the reaction of this hydroxy naphthalene and this sodium bisulfite. So once this is formed, then what is happening here is that this amine will react with it, resulting in the formation of this hemiaminal, which will get protonated by this hydride hydrogen migration from this amine to this hydroxyl group. Then water elimination will give this compound. Then again proton removal, we will get this imine compound. So once this imine is formed, then the following reaction is given here. So here what will happen is this corresponding imine will be forming with our hydrazine. So the react what is forming here will be this benzene ring. Then let if the ketone hydroxyl group was here, here double bond will come and NH, and here again phenyl ring will be there. So this species will be formed first. Then what will happen? From the phenyl ring, a deprotonation can occur and this bond will shift over here. And so this is basically which ring? In the case, this is this ring. So here we have an additional aromatic ring over this position as well. That is, it will be like this in our case. So once deprotonation happen, this bond will shift over here and this will take up one proton and this intermediate will be formed. That is, enamine kind of intermediate will be formed. Then what is happening is a type of rearrangement reaction. Then that we can say 3 3 sigmatropic kind of rearrangement reaction where this bond is breaking. That is, if it is 1 2 3 and this is 1 2 3. So this 3 3 bond is forming, 1 1 bond is breaking, and this bond is migrating over here, and this bond is migrating over here to form this species. Then what is again happening is that this H plus will protonate this NH group to form this NH2 plus, and to where this second nitrogen lone pair will attack over this imine carbon center, and then again this NH2 will get protonated and it will be removed as NH3, and then loss of proton will result in aromatization to form this compound 5. So the correct answer here is option C. So this is an example for Buchera reaction. I hope it is clear. So the mechanism whatever is following is similar only. So this hydroxynaphthalene, once it is in this form, it will form the corresponding iminium ion with this imine with this, and then this rearrangement will be happening where this NH2 will be leaving as ammonia to form this compound. So in our case, final compound we have one aromatic ring over the center. So this will be the final compound. So all this will be a completely aromatic system. Moving to the next question. Predict the major product of the following reaction. That is, this particular compound upon treatment with this palladium acetate, tetrabutyl ammonium chloride, K2CO3, DMF 100 degrees Celsius, which will be the major product out of the four options given here. So all these reactions, whichever named reactions we are discussing today, we have already discussed in the last week tutorial session, as well as we have seen these mechanisms and examples in detail in the lecture sessions as well. So which named reaction is it and what is its mechanism, which will be the major product here? So here basically the correct answer is this one, option B, and this is an example for Heck coupling reaction. So first the palladium will undergo oxidative addition. So I will show the mechanism. Yes. So the palladium zero will be generated first by the reaction of this palladium acetate with this base. So once this palladium zero is generated, this will undergo oxidative addition over this chloride. So it will be like PD and Cl. So this is the oxidative addition product, and palladium will be in 2 plus oxidation state after oxidative addition. Once the oxidative addition happens, this palladium can coordinate with this alkene over here. Palladium will coordinate with the alkene over here, then it will undergo this alkene insertion reaction, and then what is happening, beta hydride elimination will be happening to form a one more cycle here with the methyl group. So it will be forming one, two, three, four, five membered ring with the methyl group and a double bond, which formed as a result of beta hydride elimination will be resulting. So this is the basic mechanism of this, basic mechanism of Heck coupling reaction, which is basically the coupling reaction between uh, an alkyl, aryl or vinyl halide and an alkene to form an alkene by an oxidative addition of the palladium over that aryl or vinyl halide, then alkene coordination, alkene insertion, and beta hydride elimination will give the alkene. Then again reductive elimination will be regenerating our catalyst as well. I hope it is clear. So far, we have seen first one was nucleophilic aromatic substitution reaction, then the second one was Buchera reaction, and the third one is Heck coupling reaction. Moving to the next question, predict the major product of the following reaction. So this diiodo compound is treated with this copper complex in presence of NMP at RT, which will be the major product. So this is another example of coupling reaction, which is Ullmann coupling reaction. So basically what is happening here is this aromatic halides will first undergo oxidative addition with copper to form this compound. So here also oxidative addition can take place, and here also oxidative addition can take place. So it will be like This will be connected like with copper. This will be also connected with copper, and here iodide or X will be there. Then reductive elimination will connect these two bonds. So it will be 1, 2, 3, 4, 5, 6, 7. 7 membered ring, and option A will be the correct answer. So basically what is happening is that oxidative addition of one of the halides with copper to form this copper species, which will undergo again oxidative addition with the second halide to form this kind of intermediate, and then reductive elimination will eliminate this copper halide to form this carbon carbon bond to form this type of compound. So here the correct answer will be option A, and this is an example for Ullmann reaction. Now the next question is, predict the major product of the following reaction. So this compound upon treatment with this K2CO3 at 200 degrees Celsius in microwave condition using this N-methyl pyrrolidine, which will be the major product out of this four options given here. So this one is an example for Smiles reaction or Smiles rearrangement. So here what is happening is that first the base whichever we have used here will take up the proton from this nitrogen, and so here it will generate an anion. So we can say N minus will be generated and this will be NH minus. Then what is happening is that this negative charge will attack over this carbon center, and this bond will shift over this nitrogen. And once this bond is coming back over here, this bond will break. So it is now a free species. Yeah, this bond will break here. So the detailed mechanism is shown here. This bond will be breaking, and then what is happening once this is shifting over here, this bond is breaking. Okay, it is reversed, sorry for that. Okay, so once this is this NH minus, yeah, NH minus, this will be attacking over here at this center, and then this bond is breaking. No, it is attacking over this center. Okay, so what is basically happening here is that this reaction we can see first, this Miles reaction, so it will be taking up this proton. Then what is happening, it will attack over this carbon center, and this bond is shifted to here to form this kind of an intermediate. But here, the thing is that this here is, it is happening in the case of an amide, and here we don't have such amide over here. So what will happen is that this type of a cyclic intermediate is forming in this case, and then once this bond will come back over here, this will go and this will be forming, which will get protonated by the proton source whichever we are using and form this compound. So that is basically Smiles reaction or Smiles rearrangement, we can say. So here basically this aromatic substitution is happening between intramolecularly between this amino group and then this benzene ring, and this bond is like shifting over here, and this is shifting over here, and this will take up one proton from the reaction medium. And then what is happening when this is happening, first K2CO3 will be abstracting proton from this N minus. So instead of attacking at this center, so I was wrong in the beginning, it will be attacking over this center, which will result in the breakage of this bond. So that is Miles rearrangement in this case. I will explain once again. So first K2CO3 will be abstracting proton from this amine, which will be resulting in the formation of this NH minus, which will attack over this carbon center. As a result, this bond will shift over here. So this bond is basically breaking, and this bond is shifting over this nitrogen, and this nitrogen will take up the proton from some reaction source or the workup. So that will result in the formation of this compound. So the correct answer is option D. This is an example for Smiles rearrangement. Moving to the next reaction, predict the major product of the following reaction. So this terminal alkyne upon treatment with this pyrimidine derivative, that is iodo and hydroxy substituted pyridine. First, it is treated with this copper sulfate, hydroxylamine, hydrochloride, aqueous ammonia, and ethanol. And then it is treated with this pyridine under reflux condition, which will be the major product here. Okay, so this is another example for a coupling reaction. So this is basically Stephen's Castro coupling. So it is the reaction between a halide and a copper acetylene complex, which will form this type of a force and a transition state, which will result in disubstituted acetylene. So here, in the first reaction, what we will be getting, this couple product between this aryl halide and this terminal alkyne. So this copper acetylene species will be formed first, and then this will undergo oxidative addition and reductive elimination to give this one in the first step. So if it was only the first reaction, we will be getting the second option as the answer. But in the second step, since they are treating with the pyridine under heating condition, what will happen is that the pyridine will take up this hydroxyl proton. So here this negative charge will be formed, and that negative charge will be attacking over this alkene center. 1 2 3 4 5 5 membered ring will be formed, and this will get quenched upon workup or by the proton source. So that is basically happening here. So the correct answer here will be option A, not option B. If it was only the first condition, the correct answer would be option A. But again, since they are treating with the pyridine under heating condition, it will be formed. That is option A will be the correct answer. Moving to the next question. Predict the major product of the following reaction. That is, this particular compound upon treatment with this potassium amide, which will be the major product out of this four options given here. So here the correct answer is option A. And what is happening here is that, so this is happening by basically a benzene intermediate formation. So this KNH2, which is basically a base, will take up this proton. So this will move to here and this will eliminate to form this benzene intermediate. And once this benzene intermediate is formed, again this base can abstract this acidic proton because it is alpha to both of this ketone, and that will attack over this benzene and this will get protonated. So that will result in the formation of the six membered ring, 1 2 3 4 5 6, and this two ketones here. So we will be getting this option A as the major product. Moving to the next question, predict the major product of the following reaction. So this pyridine derivative is treated with this copper powder in DMF condition, which will be the major product out of these four options. So here, this is also another example for coupling reaction where we have already seen this Ullmann reaction. So this is an intermolecular coupling reaction between two molecules of this pyridine derivative. So first, oxidative addition will be giving this particular species Cu, like this maybe we can say, and then with the second molecule it will be forming this type of intermediate, and this homocoupling will be taking place. Like homocoupling means same molecule will be coupled twice to get this dimeric kind of molecule. So this is also an example for this Ullmann coupling reaction. Not going into the details of the mechanism because we have already seen this several times. Moving to the next question, predict the major product of the following reaction. So we are treating this compound with this NaNH2 in liquid ammonia followed by acid workup and this nitrous acid, which will be the major product. So here what is happening is that first this, in the presence of this NaNH2 and liquid ammonia and acid workup, this chichibabin amination is happening. So the mechanism is addition of this amide ion, NH2 minus will attack over here and this will be N minus. Once N minus will come over here, this proton will leave as NaH to form this amino product. So once that amino product is formed, then what is happening in the presence of HNO2, that NH2 is getting converted into OH and that is tautomerizing into this amide form. So this is the correct answer will be option C. First amination is taking place, then it is getting oxidized, it is getting converted into this ketone. So that was the last question of this week 9 tutorial session. Last question about the week 9 lecture videos. So far we have seen several named reactions related to aromatic nucleophilic substitution reaction. Now we will move on to the discussion of week 6 assignment questions. So the first question was this one, the major product of this reaction. So here this ketone is getting treated with this amine using LIC and BH3 and methanol, which will be the major product. So here what is happening is Bosch reduction, which is reductive amination basically. So first this ketone and this amine will react to form this iminium ion that can be reduced using this lithium or sodium cyanoborohydrate, which will be giving this amine derivative. So the correct answer will be option A. Moving to the next question, the major product of the following reaction. So this dialdehyde compound is treated with this acid in presence of this methylamine, which will be the, okay. So answer I have already given here. I think this is also clear. This is an example for this Robinson-Schorf reaction. So basically the mechanism is like that. So we are using this methylamine here, so that a lone pair of NH2 will attack over this carbonyl carbon center of one of the aldehyde, and this will form O minus, so that will be like that. Then again water molecule is getting eliminated from this, that is this OH, and this H will leave us water molecule to form this imine. And then what is happening here is that this will be deprotonated to form the corresponding enol, and that enol will be attacking over this carbon of that imine to form this particular intermediate, and then this nitrogen lone pair will attack over the second carbonyl carbon center to form this compound, and again this dehydration will take place to form this iminium ion. Once this iminium ion is formed, what is happening here is that again enol will be formed, and that enol will attack over this carbon of that iminium ion, and this type of compound is forming. Then what is happening here is that this bond will shift over here, and this CO2 will be eliminating to form this compound that can be tautomerized into this keto form. So this is enol form which is tautomerized into this keto form. Then second molecule of CO2 will be leaving to form this intermediate which is in the enol form, and upon tautomerization it will give the corresponding ketone. So this is happening here also. Here one extra oxygen is there, that is the only difference. So this is an example for a biomimetic approach to form alkaloids, and this is an example for Robinson-Schorf reaction, which is basically the condensation of 1,4 diketones with primary amine to give tropinones. Tropinones kind of system is forming. So I hope this mechanism is clear. I'll give some time to recollect this. So the next question is, this compound upon treatment with this sodium nitrate acetic acid and in second step zinc acetic acid, which will be the major product? So here the correct answer is this one, option B. And what is happening here is that first, in the presence of the sodium nitrate and acetic acid, this beta keto oxime is forming by taking up a proton from here, forming this carbanion over this center that will attack over this nitrogen, which is electrophilic in nature, to form this, and that bond will be leaving, and this will generate this beta keto oxide. Then in presence of zinc acetic acid, this NO bond is basically cleaving, that is basically it is reducing this NOH to NH2, and then condensation is happening with the second molecule, where this will again form the corresponding amine with this imine with this ketone, and then again this negative charge will attack over this carbonyl double bond to form this compound. So basically it is like double bond O, double bond N, here CO2 ET. If I am writing it in the reverse fashion, here methyl group and here CH2, no, here one carbon, then CH2, CO2 ET will be there. Then again what is happening, this negative charge will be attacking over this. I think one carbon is extra. Yeah, this carbon is extra. So it will form this 5 membered ring, and this compound will be formed. So the correct answer is option B. Then the next question is the major product of the reaction. So here this compound upon treatment with this formaldehyde and formic acid in heating condition, which will be the major product. So here what is happening, this is Eschweiler-Clark methylation. So this is basically the free amine is getting methylated under this formaldehyde formic acid heating condition, and this will continue till the tertiary amine is formed and the nitrogen is fully substituted. So the mechanism is like this nitrogen lone pair will attack over this formaldehyde to form this intermediate, and further this this aminal kind of intermediate. Then this oxygen lone pair will take up this proton from this carboxylic acid, and that will result in the elimination of water molecule, and this lone pair will fall over here, and this water molecule will be eliminated to form this iminium ion, and then that will get protonated, and this will take up, this will attack over this nitrogen will attack over this nitrogen, this that is this proton will be attacking here. Okay, that is actually basically the CO2 is eliminating, that is shown from this formic acid, the CO2 is eliminating, which will result in the formation of this compound, that is saturated compound will be formed with this positive charge on the nitrogen, and then this deprotonation will result in the formation of the substituted amine. So this is an example for Eschweiler-Clark methylation. Moving to the next question, the major product of the reaction. So this aldehyde upon treatment with this HCN ammonia in first step and HBr water in the second step, which will be the major product here. So here basically The correct answer is option A, and this is an example for Strecker amino acid synthesis. So, in the first step, with by treating with this HCN and ammonia, what is happening here? This compound is being formed. So, this nitrogen lone pair will be attacking over this carbonyl carbon center. So, here it is a mechanism to form this intermediate. So, this oxygen will take up the proton, which will get again protonated, and that water molecule will be eliminated to form this iminium ion. Then again this Cn minus will be attacking over this, that is this nitrogen will be attacking over this iminium carbon center, and this positive charge on this nitrogen will be stabilized. Then again water molecule will attack over this carbon center, and this bond will shift over here to form this intermediate imidine, maybe we can say, and that can be tautomerized into this amide form. So again water molecule is attacking, and this elimination will be resulting in the formation of this amino acid. So this is known as Strecker amino acid synthesis. So HBr will be acting as the source of H plus here, providing the acidic medium needed for the reaction. Moving to the next question, the major product of the reaction. So this carboxylic acid upon treatment in the first step with this PBr3 bromine, and in the second step with ammonia, which will be the major product. So this is an example for this Hell Vollard Zelensky reaction, which is again used in the synthesis of amino acids. So here what is happening here is that first this oxygen will coordinate with this oxygen will coordinate with this phosphorus to form this intermediate, and then that will leave as a stable phosphorus oxide species, and Br minus will attack over that, and this will result in the formation of this compound, which can exist in this enolic form as well. And once it is in the enolic form, that enol will attack on this Br plus, and Br minus will leave to get this substituted product. And then what is happening in the presence of H2O, HBr elimination is happening to form here OH, that is Br will get substituted with this hydroxyl group. So this is an example for Hell Vollard Zelensky reaction. The next one is the major product of the reaction. So this nitrile compound upon treatment with this MEoNO2 and NaOET, second step protonation, H plus treatment, acidic treatment, which will be the major product. So here the reaction is taking place via this nitronium ion. So first the base will take up this acidic proton to form this intermediate, which can exist in this form as well. Then this negative charge will attack over this electrophilic nitrogen, and this bond will shift over here to form this intermediate. Then what is happening, this OMe will leave out to stabilize the positive charge on nitrogen and to form this nitro compound, which upon acidification this nitrile group will be converted into the carboxylic acid, and CO2 elimination will result in the formation of this nitro compound. So this is an example for nitration reaction, which is going through this NO2 plus nitronium ion. Moving to the next question, the major product of the reaction. So this compound is treated with this potassium cyanide and ammonium carbonate in presence of ethanol and water. So here the correct answer is this option A, and what is happening here is that Bucherer-Berg's reaction. So In this case, we are not doing this hydrolysis step to form this amino acid. We are stopping at this hydrandoin stage. So what is happening here is that first ammonium carbonate and this ketone will react to form this iminium ion. To that, the Cn minus will attack over the center and this positive charge will be stabilized. Then from this CO2 CO3, the CO2 will be released and nitrogen will attack over that carbon to form this intermediate. Then proton transfer will result in the formation of this compound. Then this oxygen lone pair will attack over this carbon and this bond will shift over here to form this intermediate. And again, this proton transfer is taking place to form this intermediate. And then what is happening, this bond is shifting over here, this bond is breaking, and this is coming over here to form this intermediate. Then the nitrogen lone pair is attacking over this carbon center to form this compound, which can be in the resonance form by this proton migration to exist in this hydrandoin form. So that is what is happening here as well. So in the presence of KCl, ammonium carbonate, ethanol and water, Bucherer-Berg's reaction can take place. Moving to the next question, the major product of the reaction. So this enamine is treated with this lactone under acidic hydrolysis followed by treatment with NaOH. So the correct answer will be option C. And this is an example for stock enamine synthesis. So what is happening basically here is that this will attack over this center when this nitrogen lone pair will be falling over here, and this will be opened up to form this compound. So upon treatment with this H3O plus, this bond will shift over here, this will attack over here, this lactone ring will open, and correspondingly this type of an iminium ion will be formed. Then water molecule will attack over this center, that is once H2O, this lone pair will attack over this carbon center, and then this bond will shift over here and this bond will be breaking to form this keto compound. So this keto carboxylic acid compound will be the final product. So this is an example for stock enamine reaction. Moving to the last question of week 6 assignment. This compound upon treatment with this HCHO and formic acid, which will be the major product. So I am not explaining the mechanism here. We have already seen this. This is an example for Ischweiler-Clack methylation, where this nitrogen, free nitrogen, will get methylated. So it will continue to get methylated until the tertiary amine is formed. So here the correct answer will be option A. So that was about the week 9 tutorial session. So here we have seen some of the named reactions which we have seen in the week 9 lectures regarding the nucleophilic aromatic substitution reaction, and we have already discussed the week 6 assignment questions so that we can brush up some of the topics discussed during week 6 lectures. I hope this session was useful. Thank you for joining and thank you for listening. Thank you.